The fundamental currency of our universe is energy. It is the invisible force that drives every aspect of our existence. It lights our homes, grows our food, powers our cities, and fuels our dreams. Without energy, life as we know it would cease to exist. But as our world grows, so does our hunger for energy. And with that hunger comes a pressing question. Where will this energy come from? For centuries, we've relied on burning fossil fuels, coal, oil, and gas, to power our civilizations. But we've reached a tipping point. The cost of these energy sources is no longer just financial. It's environmental, social, and existential. The air we breathe is polluted, the climate is changing, and the delicate balance of our planet is being disrupted. We need a new way forward, a way that doesn't just sustain us, but propels us into a brighter, cleaner, and more equitable future. Could fusion power be the answer? Could it be the energy of the future? Imagine a world where energy is limitless, clean, and accessible to all. A world where the power of the stars is harnessed, not in some distant galaxy, but right here on Earth. This isn't science fiction. This is the promise of fusion power. The sun, that blazing ball of fire in our sky, has been shining for billions of years, powered by the process of nuclear fusion. It's the same process that lights up every star in the universe. And if we could replicate even a fraction of that power here on Earth, it would change everything. But how close are we to making this dream a reality? And what stands in our way? Let's dive into the science, the challenges, and the hope that fusion power brings. At its core, fusion is the process of combining light atomic nuclei to form heavier ones, releasing enormous amounts of energy in the process. It's the opposite of nuclear fission, which powers today's nuclear reactors by splitting heavy atoms like uranium. Fusion, on the other hand, uses isotopes of hydrogen, deuterium, and tritium as fuel. These isotopes are abundant, especially deuterium, which can be extracted from seawater. The beauty of fusion lies in its simplicity and its potential. A single glass of seawater could theoretically produce as much energy as burning a barrel of oil, without the harmful emissions or long-lived radioactive waste. It's the ultimate clean energy source. But there's a catch. Fusion requires unimaginable temperatures and pressures to work. We're talking about millions of degrees Celsius, hotter than the core of the sun. At these temperatures, atoms are stripped of their electrons, creating a state of matter called plasma. In this superheated soup, atomic nuclei collide with enough force to overcome their natural repulsion and fuse together, releasing energy in the process. The challenge, of course, is containing this plasma. On the sun, gravity does the job, compressing the plasma to the point where fusion occurs naturally. But here on Earth, we don't have the luxury of such immense gravitational forces. So we've had to get creative. Scientists have developed two main approaches to achieving fusion: magnetic confinement and inertial confinement. Magnetic confinement uses powerful magnetic fields to contain and compress the plasma in a donut-shaped device called a tokamak. The most famous example of this is the ITER project in France, a multinational effort to build the world's largest tokamak. ITER's superconducting magnets are cooled to near absolute zero, creating some of the most extreme temperature gradients in the known universe. The goal is to sustain a fusion reaction long enough to produce more energy than it consumes, a milestone known as ignition. Inertial confinement, on the other hand, takes a different approach. Instead of using magnets, It relies on incredibly powerful lasers to compress a tiny pellet of fusion fuel. The lasers deliver a precise burst of energy, heating the surface of the pellet and causing it to implode. For a fraction of a second, the fuel becomes hot and dense enough to fuse. The National Ignition Facility in the United States is at the forefront of this research, using one of the most powerful lasers ever built to conduct groundbreaking experiments. Both approaches have their strengths and challenges, but they share a common goal: to unlock the power of fusion and bring it to the world. But here's the reality: fusion is hard, really hard. Despite decades of research and billions of dollars in investment, we're still not there yet. The technical challenges are immense. Containing plasma at millions of degrees is no small feat. The materials used in fusion reactors must withstand extreme heat and radiation without degrading. And then there's the issue of energy input versus output. So far, every fusion experiment has required more energy to initiate and sustain the reaction than it has produced. In other words, we're still in the red. But that doesn't mean fusion is a lost cause. Far from it. The progress we've made is nothing short of extraordinary. We've gone from barely understanding the physics of fusion to building massive experimental reactors that are pushing the boundaries of what's possible. The question isn't whether fusion can work, it's when. And when it does work, the implications are staggering. Fusion power could provide a nearly limitless supply of clean energy, with no greenhouse gas emissions and minimal radioactive waste. Unlike fossil fuels, which are finite and unevenly distributed, fusion fuel is abundant and accessible. Deuterium can be extracted from seawater, and tritium can be bred from lithium, a relatively common metal. And if we ever run out of tritium, there's another option: helium-3. This rare isotope of helium is even better suited for fusion reactions, producing more energy and less radiation. The catch? Helium-3 is incredibly scarce on Earth, but it's not scarce everywhere. The Moon, for example, is thought to have vast reserves of helium-3, deposited over billions of years by the solar wind. Mining the Moon for helium-3 might sound like science fiction, but it's a real possibility, one that could solve our energy problems for thousands of years to come. But let's not get ahead of ourselves. Fusion power is still in its infancy, and there are many hurdles to overcome. One of the biggest is cost. Building a fusion reactor is astronomically expensive. The ITER project, for example, has a price tag of over $20 billion. And that's just for an experimental reactor. Commercial fusion plants would likely cost even more. Critics argue that this money could be better spent on other clean energy technologies, like solar, wind, and advanced nuclear fission, which are already proven and scalable. They have a point. But fusion offers something these technologies can't: the promise of virtually unlimited energy with minimal environmental impact. It's a gamble, to be sure, but one with potentially world-changing rewards. And then there's the question of safety. Fusion reactors are inherently safer than traditional nuclear power plants. There's no risk of a catastrophic meltdown because the reaction requires precise conditions to sustain itself. If something goes wrong, if the plasma escapes or the magnetic field fails, the reaction simply stops. No explosion, no runaway chain reaction, just a cooling plasma and a return to normalcy. That said, fusion isn't entirely risk-free. Tritium, one of the primary fuels, is radioactive and could pose a threat if released into the environment. But the amounts used in fusion reactors are small, and the risk of a significant leak is low. Compared to the dangers of fossil fuels or even conventional nuclear power, fusion is a far safer option. So where does that leave us? Is fusion power the energy of the future, or is it a pipe dream? The truth is, we don't know yet. What we do know is that the stakes couldn't be higher. The world is facing an energy crisis unlike anything we've seen before. Climate change, resource depletion, and geopolitical instability are all tied to our reliance on fossil fuels. We need a solution, and we need it fast. Fusion power offers a glimmer of hope, a vision of a world powered by the stars, where energy is clean, abundant, and accessible to all. But realizing that vision will require unprecedented levels of innovation, collaboration, and investment. It will require us to dream big and take risks. And it will require us to believe in the power of human ingenuity to overcome even the most daunting challenges. The journey to fusion power is far from over. There will be setbacks and disappointments along the way. But every experiment, every breakthrough, brings us one step closer to the goal. And when we finally achieve it, the rewards will be beyond measure. A world powered by fusion would be a world transformed. It would be a world where energy is no longer a source of conflict, but a force for good. A world where we can focus on building a better future, free from the constraints of finite resources and environmental degradation. That's the promise of fusion power. And that's why, despite the challenges, we must keep pushing forward. Because the energy of the future isn't just about powering our homes and cities, it's about powering our dreams, and fusion just might be the key to unlocking them. The story of fusion power is not just a scientific endeavor, it's a testament to human ambition and our relentless pursuit of progress. It's about looking at the stars and saying, we can do that too. It's about taking the raw, untamed forces of the universe and bending them to our will. But it's also a story of humility. Fusion reminds us that we are small, that the challenges we face are immense, and that the path to greatness is fraught with obstacles. Yet, it's precisely this combination of ambition and humility that makes the pursuit of fusion so compelling. It's a reminder that even the most audacious dreams are within our reach if we're willing to work for them. Consider this. Every second, the sun converts 600 million tons of hydrogen into helium through fusion, releasing enough energy to power our planet for hundreds of thousands of years. That's the scale we're dealing with. And while we may never replicate the sun's sheer power, even harnessing a fraction of it could revolutionize our world. Imagine a future where energy poverty is a thing of the past, where remote villages and bustling cities alike have access to clean, reliable power. Imagine a world where we no longer have to choose between economic growth and environmental preservation, where the air is clean, the water is pure, and the climate is stable. This is the future fusion power could help us build. But let's not sugarcoat it. Fusion is not a magic bullet. It's not going to solve all our problems overnight. Even if we achieve a breakthrough tomorrow, it will take decades to build the infrastructure needed to bring fusion power to the masses. And in the meantime, we still have to deal with the pressing challenges of climate change, energy inequality, and resource depletion. That's why fusion isn't just about the future, it's about the present too. It's about investing in research and development today so that we can reap the rewards tomorrow. It's about laying the groundwork for a better world, even if we may not live to see it. And let's not forget the human element. Behind every fusion experiment, every laser pulse, every magnetic field, there are countless scientists, engineers, and dreamers working tirelessly to make this vision a reality. These are the unsung heroes of the fusion story, the people who spend their lives in labs and control rooms, poring over data and tweaking equations, all in the hope of unlocking one of the universe's greatest secrets. Their work is a reminder that progress is not just about technology, it's about people. It's about curiosity, perseverance, and the belief that we can make the world a better place. There's also something deeply poetic about fusion power. It's a technology that mirrors the very processes that created the elements we're made of. Every atom in our bodies, every molecule in the air we breathe, was forged in the heart of a star. Fusion is the cosmic alchemy that turned hydrogen into helium, helium into carbon, and carbon into the building blocks of life. By harnessing fusion, we're not just tapping into a new energy source, we're connecting with the very essence of the universe. We're taking part in a story that began billions of years ago, and we're writing the next chapter. But for all its promise, fusion power is not without its skeptics. Some argue that it's a distraction, that we should focus on improving the technologies we already have, rather than chasing a distant dream. And they're not entirely wrong. Solar, wind, and other renewable energy sources have made incredible strides in recent years, and they're already making a difference. But here's the thing, we don't have to choose. We can, and should, pursue multiple paths at once. Fusion isn't a replacement for other clean energy technologies, it's a complement. It's a way to diversify our energy portfolio, to ensure that we have all the tools we need to tackle the challenges ahead. And let's be honest, fusion is exciting. It captures the imagination in a way that few other technologies can. It's the stuff of science fiction, of starry-eyed dreams and bold visions of the future. And that excitement matters. It inspires the next generation of scientists and engineers. It sparks conversations and debates. It reminds us that the future is not something that happens to us. It's something we create. Fusion power is a symbol of what humanity can achieve when we dare to dream big and work together. So where do we go from here? The road to fusion power is long and uncertain, but it's a road worth traveling. It's a journey that will test our limits, challenge our assumptions, and push us to new heights. And along the way, it will teach us something profound about ourselves. It will remind us that we are capable of greatness, that we can overcome even the most daunting challenges, and that the future is ours to shape. In the end, fusion power is more than just a technology. It's a symbol of hope. It's a reminder that no matter how dark things may seem, there's always a brighter future on the horizon. It's a call to action, a challenge to rise above our differences and work together for the common good. And it's a testament to the power of human ingenuity, to our ability to take the impossible and make it real. So is fusion power the energy of the future? The answer is, it could be, but only if we're willing to put in the work, to take the risks, and to believe in the power of our dreams. The stars have given us a glimpse of what's possible. Now it's up to us to reach out and seize it. The future is waiting, and with fusion power, it just might be brighter than we ever imagined.